we are in our next tutorial for this section. This section is implicit differentiation. Just to do a quick recap. We talked about explicit form versus implicit form. We talked about how there's times when implicit form can be rewritten as explicit to make the differentiation a lot easier. But many times when it's an implicit form, it's just too much to go through and solve for y. So when we took the derivative with respect to x of a y term, you have to have dy dx. I did a quick example with the Pythagorean theorem. If you took the derivative with respect to x, it is 2a dA over dx and so forth. All right, then we just got done with the tutorial about talking the 4 steps involved in implicit differentiation. I will give you a hint that you're going to get pretty good at this, and you're probably going to be able to do it in 2 steps. In any case, the first example here, find the slope of the curve with this equation, x squared plus 2x plus y squared plus y, or 2y equals 23. And we're going to find the slope at the indicated point, 3, -4, in the tangent line. So the first step is I'm going to go ahead and take the derivative implicitly. So step 1, take the derivative of both sides. So when you do that, you're going to get a 2x plus 2 plus 2y dy dx plus 2 dy dx equals 0. The derivative of 23 is 0. That's step 1. Step 2, send all dy dx to the left side. So just looking at this does not have a dy dx, so it's going to go over. That as well is going to get over. This stays and this stays. So step number 2, put my equal sign. The negative 2x, that's good, send it, and that also the negative 2. So I just sent those 2 first terms over, and what's left is a 2y dy dx plus 2 dy dx. Step 3 is factor out dy dx. So if I'm looking at the left-hand side here, you can see that they both share, there we go. They both share a dy dx, so let's factor out a dy dx. So if we factor it out, we get 2y plus 2 equals negative 2x minus 2. The fourth step is solving for dy dx, and that's simply just dividing. Dividing by the grouping of 2y plus 2. And that is your differential equation for that implicit equation. Now, there are more things to do here. We want to find the slope at the indicated point. So to answer that question, we're going to go ahead and substitute the point 3, -4 into the derivative. So it's negative 2 times 3 minus 2. 2 times -4 plus 2. Let's see, we get negative 6 minus 2 is negative 8 on top. Right, negative 8 plus a 2 is going to be negative 6. You got googe on the negative signs. You can factor out a 2, and we're going to end up with a slope of 4, let's say a y, of 4/3. I'm not going to worry about the tangent line. We're just going to focus on taking the derivative implicitly, going through the steps. All right, let's move down to the next one. Let's go ahead and take the derivative. I did want to mention before I do this one, dy dx. That's the same thing as y prime, right? So instead of writing dy dx, you could write y prime. So for the first step, I'm going to take the derivative of both sides, and I see here I'm going to have to do the product rule. So the product rule is going to be the first times the derivative of the second, which is a 1, but you have to put dy dx. or you could put y prime, plus the second, which is y, times the derivative of the first, 15x squared. To continue on, the derivative of the 3y to the fourth would be 12y cubed y prime, or dy dx, equals, the other side is a 1. I'm going to clean this up, and I'm going to go ahead and rewrite my dy dx as the y primes. So I'm going to have a 5x cubed y prime plus 15x squared y plus 12y cubed y prime equal to 1. You could keep them dy dx's if you want. I just changed them to y prime. That is step one. Step two is to get everything that is not a dy dx or a y prime on the other side. So 5x cubed y prime stays. The 15, I'm going to subtract the 15x squared y. The positive 12y cubed y prime, that stays. Okay, so now I'm on I'm on my step three. I got to factor out my dy dx's or my y prime. And if I do that, I'll have a 5x cubed plus 12y cubed equals 1 minus 15 x squared y. And your last step, 1 minus 15 x squared y divided by 5x cubed plus 12y cubed. And that is the derivative of this function, or of this implicit form. Okay, let's go down to the next one. I'm going to disregard the second derivative. I'm not going to worry about that this year. We're going to go ahead and take the derivative implicitly. I know you could solve this and find, solve it for y and do it that way, but this, we're going to go ahead and practice implicit form. So when you take the derivative, it's going to be 6x squared plus 12y cubed y prime equal to 0. Now I'm going to give the answer right here. I'm going to skip all those other steps, and here's how you can do it. Y prime, draw a big fraction bar. If it doesn't have a y prime, it's going to go on top. So for example, this has to go to the other side. So it becomes a negative. Now there's no other y prime, so there's no factoring here. I just have to divide, divide by this term. 12y cubed. Excuse me. So I'm just going to go ahead and simplify, and that is your derivative. Okay, I think I'm going to go ahead and just talk to you guys about the next two, the rational powers here, and that will be it. So if I have the square root y, I'm going to go ahead and I'm taking the derivative. I'm going to rewrite that as a grouping raised to the 1/2. So this is almost like the chain rule, where you're going to take the derivative, and it's going to be the outside. So the 1/2 comes down to negative 1/2, and then the derivative of your y is a 1, and don't forget to put your dy dx. So if you take a look at my next two examples here, I'm going to rewrite my cube roots of y squared as y raised to the 2/3. And I'm going to take the derivative of both sides, and I'm showing you all the steps in between here. The derivative of x is a 1. The derivative of y to the 2/3 would be 2/3 y. Subtract 1 would be negative 1/3. Don't forget to take the derivative of y, which is dy dx. And you got to solve for dy dx or solve for y prime, which means I'm going to multiply, or I guess I could, let's see here. Let me let me rewrite it. It might be easier to see. If I rewrite this, it would be a 2 here, 3 on bottom. It's y to the 1/3, and it's going to be times y prime. And you got to solve for y prime. So you're going to multiply by the reciprocal. So 3's up top, 2's on bottom, and y to the 1/3. And of course, you're going to rewrite that as y prime equals 3/2 y to the 1/3. The next example, if I take the derivative of both sides, it's a 1, negative 1/5. Rewrite the inside. And I'm going to subtract 1, so that's negative 6/5. The derivative of the inside is cosine, so I write negative sine. I rewrite that inside. And the derivative of the inside is a y, so it's a 1 y prime. Excuse me, so I'm going to go ahead and solve. Actually, I'm going to clean this up. I have a googe right here. I got a negative 1/5 and a negative right here. Let's see, is there anything else I can clean up here? I'm going to have a cosine y, and that's going to be, I guess I'll write it this way, negative 6/5. I'm going to have a sine y right here, and then a y prime. Okay, so if I'm solving for y prime, I am going to, well, this is technically on the bottom, or I can rewrite that so it's going to be on the top. This is actually on the top. I'm going to divide that one out, so that's going to end up on the bottom. So sine y is on the bottom, and cosine 6/5 y is on top. I did skip a lot of the algebra on that. Maybe I should show that before I wrap this video up. All right, so I'm just going to rewrite this. This cosine goes on the bottom. Cosine y 6/5. Sine y goes on top times y prime. I want to get y prime all by itself, so I'm going to multiply by cosine y raised to the 6/5. I'm going to divide by sine y. And if I do it to one side, you got to do it to the other side. And that's how I got the answer. Okay, so that is the conclusion of implicit differentiation. The biggest thing is putting your dy dx after taking the derivative of a y term. You can follow these steps, differentiate both sides, get your dy's, dx's to both sides, factor it out, and then solve. A lot of people skip those steps and go right down to differentiate both sides, and then go right down to your dy dx in two moves. If you have any questions, let me know.